This video is an introduction to Apex EBSD. There are two ways of starting this application. The first is to use the Apex EBSD icon. This launches Apex EBSD in a standalone mode. The second option is to use the Apex Suite icon, which launches both Apex EBSD as well as Apex EDS together so they can easily be switched between the two during operation. I'm going to go ahead and select Apex Suite. This starts the software. It initializes both the EDS and EBSD detectors and checks to make sure they're operating correctly. It also initializes the slides on the EBSD detector as well as the EDS detector if it's available, as well as the imaging tool of the program. Once it's done with this, we then need to log into the system. So I'm going to type in my username, my password. You can see it shows status indications to show both detectors are working correctly. It sets up the software, and when I've selected Suite mode, it launches in the EDS mode first. I need to set up a project, so I'm going to create an Apex Intro video project, and I'm looking at a nickel alloy. You'll see it saves the data in what's called an HDF5 file, which is a container file format that contains both the EDS and EBSD data. We can specify where we want to save this. In this case, I've selected the EDAX data, which is a secondary hard drive on my computer. So we can select different locations to save the data. I'm going to hit save. It's now going to go to the program. Now you can see we started in the EDS mode. I can go to the EBSD mode. It's easy to switch back and forth between the two. The user interface follows a ribbon bar concept for the user interface. So within this, we have different tabs which access different functions, different application functions for the software. And within each tab, we have different icons for the relevant features within that section. So we're going to start working left to right. The camera tab, of course, operates and sets up the camera. So the first thing we've done is I've set up the sample so that I'm tilted to 70 degrees and positioned in the correct position. I can collect an image to show the sample of interest. This is just the secondary electron detector. So I'm in the correct position, in the correct working distance. I'm ready to insert my detector. I can insert it here by pressing the insert button. You can hear the slide start moving in. The target position is fully inserted, which is 0. We see the current position as we go. I often watch this on the infrared camera just to see that it's moving correctly. But of course, the limit switches and the range have been set up during the installation process. Now, the next section will be the pattern section. This is where we can set up the camera. And so for the EBSD cameras, we set up basically the image resolution and the exposure time to get the pattern we want. We have a number of different options ranging from best pattern, which is the highest pixel resolution, lowest gain, highest quality pattern, up to the ultra fast, which is designed to get the highest throughput. I'll select reduce noise here to start. So I select this. Press this button, and it's going to optimize the camera to operate in a binned mode. So in this case, it's 4x4. I'm running a Velocity Super camera, but we'll run it in a way that it'll be the same for a Velocity Plus or a Velocity Super. So our binning here is 4x4, but we're at a pretty high signal level to get good signal to noise. So then if I choose to put it into external control, I can see that I see the pattern. I can select my background processing. In this case, I'll just select standard to see the background corrected pattern. I get good patterns here. So essentially now on the camera tab, I've set up the camera. So from here, I can go to the pattern mode. I can move my cursor along to see both the live pattern on the right. When I let go, I see the index pattern and I see the indexing information. Now, by default, I'm looking at the FCC or face-centered cubic and BCC body-centered cubic default structure files. I mentioned earlier we're looking at a nickel alloy, so the FCC file works just fine. But if I want to be correct, I'm going to go ahead and say search for nickel. Looking by keyword, so these are all ones that have nickel in it, and if I scroll down, I'm going to find just the nickel alloy. If I put that in here, and I can remove the BCC and the FCC, and I hit OK. If I come recollect here, now you'll see it indexes just as nickel. We can search. When we do the search, we can search by keyword, by elements. We can sort by crystallography, and we can search multiple databases, but I've just started with our basic default database. For introduction, I'm just going to go ahead and use this as the basic. So from here, now that we have the phase collected, we see that we're indexing. The next step would be to say I want to go to the scan page. And so working across here, I have my image collected. If I choose to collect it again, because I've inserted the detector, the contrast may be a little bit different. But this is my area of interest. And I could hit here, just collect using the defaults that are presented here. But I want to go over what the different options are. Standard is a standard rectangular field of view. You can see it's filling up the complete field of view. If I choose to grab this, I can make it smaller. I can reposition it. I can hit this to go back to full field of view. You'll see as I'm changing these numbers, the values of the X and Y size and X and Y start position change. That's being showed in the details area. One thing I'd like to note, if I go to my layout, I can go to just a standard map view where the details are not shown. Generally, I tend to have that on, but that's a user preference. Beyond the standard mode, we have the freeform mode where I could say I want to draw area of interest, and it'll scan just that area. If I wanted to start a line scan, I could do a line scan in a place, or I could do a combo scan where it would go from multiple fields and stitch them together. Now I'm going to go ahead and just keep it to a standard scan for now. The next setting is the step size. So we have three different options: coarse, medium, and fine, as well as a manual setting. And these will select different step sizes based on the magnification to give a certain number of points based on the camera you're using. So for the velocity, coarse gives it somewhere around 25,000-30,000 points. Medium gets us somewhere 300,000-400,000 points. And fine gets us somewhere near 1,000,000 points. So I'm going to go ahead and select a medium step size to show this. I have the option of collecting simultaneous data. I have the option of sending to a report when we're finished. If I choose select report, I can come down to my report template here, and I can select which report I want to do. So let's say I wanted to do a basic review. I'd select that and it loads that in. So when we're done, that's what would be available. Now, the important one here, you can see we're still in reduced noise mode. I probably don't want to go that speed. That's going to give us around 500 frames a second. It's pretty easy with both velocities to run in fast mode. So I'm going to select that. I'm going to hit that button to optimize it for a scanning speed that's a little bit faster. So you can see now we're getting a few more frames a second. And our phases are still selected through here. So at this point, we can go ahead and hit the collect button to collect the data. And as we do this, it's going to show us the map as it goes along. And so we have a couple of different things to show while we're collecting. We have color-coded and grayscale maps that are being shown. So in this case, we're looking at the inverse pull figure. If I want to click here, it shows me where the legend is for that inverse pull figure. I can turn that on and off. If I have that off, I'm only seeing the image quality map. And for the grayscale, I can look at the confidence index, image quality, the SEM signal, and the Prius signal. And the Prius signal, we can see the top, the center, or the bottom. So, these are some dynamical information that allows us to go. As we're collecting, you'll see we also have this colored bar here that shows the confidence index, average confidence index as a function of position. And when it's green, it's good. If it's red, it's bad. If it's yellow, it's sort of at the cutoff value. And if it's green, then it's good to proceed. Generally, if you're in the red or yellow section, you either need to, there's three things. You either need to increase your exposure time, increase your beam current or evaluate to make sure your sample is prepared correctly, so it will give you a good diffraction pattern. In addition to seeing these different views, we can also see here the patterns that are being generated while we're mapping. This shows the bands that are being detected. This shows the Huff transform. This shows the indexing. And this shows the crystal view. And then we can also look at the pole figure. Now, of course, you start looking at too many points, this doesn't necessarily help so much, but it gives you some idea of a dynamic feedback. And if you're looking at a single crystal or solidification, sometimes you see something interesting. And then in the summary view, we see that we're about 72% completed now. We're running just under 2,500 points per second, and the number of points completed, the number remaining, and we have about 30 seconds to go. And so we'll go ahead and let that complete. Again, I mentioned this data is being saved into an HDF5 file. That's a portable file. It can be used both for EDS and EBSD data, and can be used within the Apex review mode to look at EDS data, and OIM analysis to look at the EBSD data for further analysis. So now that we're nearing completion, it's going to finish, and it's going to go ahead and generate the report that I selected. So now it starts OIM analysis, uses a template within OIM analysis to generate the selected maps. And then we'll put this into the report format. This is all set up within the setup process to create a Word file that shows whatever information I wanted from this basic report. And then the OIM analysis is finished. We have a little summary bar here. Tells me the number of points, the indexing points, the average CI, the average fit. I can go ahead and click done. We're then ready to move on to the next step. If we want to see the data that we've collected, I can click up here to bring up my project tree. And this shows you the organization of the data within the HDF5 file. So we have our nickel alloy, area 1, map 1, OIM map. If I want to open this directly in OIM analysis, I can just double click on this. It sends this to OIM analysis, and then I can proceed to do my work through here. The other thing we can do, if we go ahead and minimize this, if you just come to open OIM analysis and you want to open the data file, I can say open new data set, and I'm on my EDAX data drive. Here's my HDF5 file here for the intro video. When it looks at this, again, it's a container file because it contains multiple data sets. So it says I want to just select OIM map 1 here, add this to my data set, and it'll open that for OIM analysis. This gives a brief introduction to how Apex EBSD can be run from start to finish.